Time dilation is a fascinating consequence of Albert Einstein's theory of special relativity. It's the phenomenon where time appears to pass at different rates for observers in relative motion. In simple terms, when you're moving at a significant fraction of the speed of light, time will appear to pass more slowly for you compared to someone who is at rest.
So here it is. You may remember, or you may have heard, that Einstein's relativity,
Right.
more specifically, you learn this in special theory of relativity, where the faster you move, the slower time ticks for you,
Right.
as others view it.
Relative to the observer.
Relative to the observer, correct. You don't know anything's happening. Your clock still ticks as far, you still got your heartbeat, all of this. Okay, so this is not a physiological thing. It's an actual property of the fabric of space and time under those conditions.
Wow.
So I watch you fly by, and the faster you go, the slower time ticks for you. Okay? So not only does speed do this, also the strength of a gravitational field will have the same effect on you. The stronger the gravitational field is, the slower time ticks for you. And that wasn't formulated until his general theory of relativity, 10 years later. That took a lot more math and deeper insights into the universe.
But once again, it makes sense because you're dealing with the fabric of space-time.
It's the fabric of space-time, correct.
Wow, okay.
But initially, when formulated, you're thinking it's just because you're moving.
Right.
But it's actually way deeper than that. And that's why that one, oh, by the way, his original special theory of relativity was not called that. The title of the research paper was On the Electrodynamics of Moving Bodies.
What?
Okay, that was the title. We would later call it the special theory of relativity because it was a special case of what would later then be called the general theory of relativity. While we're there, let me just slip this in. The GPS satellites orbit higher than like the space station and other things that are in what we call low Earth orbit.
Low Earth orbit.
They're in like MEO, the middle orbit. That is far enough away from Earth's source of gravity for them to have a measurably different space-time condition. So that their clocks tick faster than our clocks on Earth's surface.
Wow.
But we get precise timings from geosynchronous satellites. So how does this work? We pre-correct the time signal from the GPS satellites to compensate for Einstein's general theory of relativity so that by the time the time reaches us, it's been properly corrected and it matters to us and our space-time continuum, not the one that's in middle Earth orbit.
Time dilation is a fundamental concept in the theory of special relativity and has been confirmed through numerous experiments. It has profound implications for our understanding of the universe and how time and space are intertwined in the fabric of space-time. It is important to note that time dilation only becomes significant at velocities approaching a significant fraction of the speed of light, so in everyday life, we don't notice this effect. Did you learn something? Like and subscribe for more.